Hi learners and welcome back to my channel. In today's video, we are going to cover Class 7 NCERT Reading and Marking, a chemistry chapter, Science, Acids, Bases and Salts. Complete NCERT reading in one shot and perfect for revision with tips and tricks. It will be beneficial if you sit along with the NCERT and mark with me so that you can make most of this session. So let's get started. This is the basic introduction of the lesson, where they have asked us to taste various substances around us and classify them as sour, bitter, sweet, salty, etc. But also giving a caution that do not taste anything unless asked, neither should we touch anything, as sometimes things may be corrosive around us or non-edible. Now let's get into the crux of the chapter, that is acids and bases. So they have classified acids as substances which are sour in taste, for example, curd, lemon juice, orange juice, vinegar, etc. And such substances, the chemical nature is acidic. It is derived from a Latin word, which is very important and can be asked for 1 mark. Also, bases, which is the opposite of acids, they are bitter in taste and soapy to touch, brittle as well, and they are known as basic. For example, baking soda. This is a basic substance. Now, we cannot touch or taste every substance because, as I said, some may be corrosive in nature, causing damage, high-scale damage. So, we have certain indicators. Literally, they indicate whether something is acidic, basic, or neutral. So, when they are added in a solution, either acidic or basic, they change color, and we have many naturally occurring indicators as well. According to Arrhenius concept, this is extra information. According to Arrhenius concept, acids are substances that give H plus ions in water, and bases are substances which give OH minus ions in water. Now, litmus. This is one of the natural indicator and it is extracted from lichens. Lichens, as we know, is a symbiotic relation between fungus and algae, as we had seen in chapter 1, nutrition in plants. So this is actually our source of lichen, or first natural indicator. And in distilled water, it is purple in color. And when added to acidic solution and basic solution, it changes color. Now I will give you a trick to remember this. Now, when it comes to litmus, this is only for litmus. In other indicators, the color change is different for acid and base. In litmus, acid always turns to red, whereas bases, they always turn to blue color. Litmus I can use in 2 forms. One form is the solution form, that is purple color in distilled water, solution form. Other one is strips of paper. You must have heard of litmus paper. So litmus paper, again I have blue litmus and red litmus. So when blue litmus I dip in an acidic solution, it turns red. Whereas blue litmus, if I put in a basic solution, it's going to be blue. So no change. Whereas red litmus, when I put it in acidic solution, it will be red, no change. Whereas that red litmus, when I put in basic solution, it is going to change blue. So whatever be the litmus, acid will always turn into red, bases will always turn litmus into blue. If it is a solution, the solution of when put in acid will turn into red, whereas basic, it will turn into blue. So just remember acid to red, base to blue. But I will as well give you a trick to remember. For bases, always remember B cube. B cube is nothing but, I'll write it here as I don't have space. Or I'll just erase a little bit. Yes. So B cube stands for bases are bitter and they turn litmus to blue. So this is the B cube method for bases. Bases are bitter and they turn litmus into blue. It can be red litmus, it can be blue litmus also, but it turns into blue. Now the solutions which don't change the color of either red or blue litmus paper, there will be no change. Then they are known as neutral. They are neither acidic nor basic, they're neutral. So litmus won't get affected at all. Now the next natural indicator is turmeric, something we all know, all of us have it in our kitchen. Now they have given an activity. Do make sure to read through the activity. But the main idea is it turns bases into dark reddish brown color. And they have thus given two activities which can be asked for reasoning questions. So do not skip them just because they're activities. They can be asked for reasoning questions, especially this one. A turmeric stain on white shirt turns to red when it is washed with soap. Why? Because soap solution is basic. We'll soon see. Soap solution is basic and the soap solution is basic. So base plus turmeric is going to give this color. It turns to red. Now, also here it is given, they're just various applications of the same idea that base plus turmeric gives reddish brown. So this is about making a greeting card with turmeric and soap. Next is China rose. Again, we can get it from nature, so it's a natural indicator. So China rose, and this is an activity. Do read through it. The important part is here, which can be asked for 1 mark, the conversions. So I will be giving you another trick to remember this. So China rose indicator, it turns acidic solution to dark pink or magenta, whereas basic solutions to green. Now, all I want you to remember is that this is China rose. So imagine a flower like this. Imagine a flower. Okay, I'm going to just slightly fill some color in the flower so that you can see the purple, but the color which it turns into is magenta. It's like dark pink, not purple. And imagine a stem for this, like a stem. Now China rose, so I drew a flower. Now all you have to remember is this base part as a base. This is the base of the flower, for example. And when this China rose is put into a basic solution, it turns green. For base, this is the base of the plant. Now, as this is the base, this is my acid part, this turns into magenta or dark pink. This is for China rose. So nothing at all, it's just China rose, and this is a trick. Imagine a flower with the petals in magenta color, the base, the leaf, the stem as green color. So the base of the plant is going to be green and the top flower is magenta. So acid, imagine the top part as acid because we have taken our base as obviously base. So base, when China rose is added to a base, it turns green, whereas when it's added to an acid, it turns into magenta. Sorry, this is acid. Acid. Yes, dark pink or magenta. This is not purple, this is magenta. Okay, let's move forward. Now, acid rain. This is very important and can be asked without even mentioning the term acid rain in the question. So, you must have heard of this acid rain as such. So, when emissions from cars as pollutants, for example, carbon dioxide, sulfur dioxide, or even nitrogen dioxide are released into the air, they mix with the raindrops, the moisture present in the air, they mix with these and they react to form carbonic acid, H2CO3 carbonic acid, H2SO4 sulfuric acid, HNO3 nitric acid respectively. So carbon dioxide will form carbonic acid, sulfur dioxide will form sulfuric acid, nitrogen dioxide will form nitric acid. Now they are acid, and so with rain, acid rain. Now they are very harmful as acids, especially these acids are very corrosive, very harmful in nature. They cause severe burns and damage. And so in the chemistry lab, we have to be very, very, very careful. And so there was a caution, don't touch or taste anything. It can have severe side effects and cause lot of damage, and it burns the substance. So acid rain, it causes damage to buildings, historical monuments, plants and animals. Example of this is Taj Mahal. And thus pollution causes damage to such historical monuments, important landmarks which are the pride of nations. And that is why we say that do not pollute the environment, especially in cars when we go. Use, there are so many ways to reduce air pollution. So when we do that, we ultimately protecting so many things around us. Now this can be asked for a reasoning question. They may name a historical monument, they may give a picture, or they may say that acid rain causes damage to historical monuments. They turn yellow, yellowish, you can say. They turn yellowish. And why is this and how does it happen? Then you have to write what is given in this box. Now let us move on to neutralization. This is something that is very easy, interesting, and important. So first of all, we will let me introduce you to one more indicator, phenolphthalein. So phenolphthalein in acidic solution, it remains colorless, whereas in basic solution, it gives a pink color. Now this is the important point. There is an activity to read through the activity. So the important point is phenolphthalein gives pink when it's in base, whereas in acidic, it remains colorless. Now let us see what neutralization is. Now when an acidic solution is mixed with the basic solution, both of them neutralize the effect of each other. For example, if a strong person is fighting with another strong person, then you can say no one wins. Suppose if it is a computer system, for example, and we give two things the same value, then ultimately nothing happens. The best example, a weighing scale. You can take a weighing scale. This is acidic, this is basic. If I have, say, three balls here and three balls here, both are going to neutralize each other. So finally, the resultant solution is going to be neutral, but it is going to form a salt. It is going to form a salt when they react, because when two substances react, they give a product. So they are going to form a salt. And also along with the salt, water and some heat is also evolved in this reaction. Whereas if I suppose add 3 more balls of acid, it is not going to neutralize. In fact, the reaction is going to be called a neutralization reaction, but my salt is going to be an acidic salt. Instead, if I add many more of base, now base is more, so I'm going to be getting a basic salt. Then both are, if both are equally strong, acid is equally strong, basic is equally strong, or if I have a weak base and a weak base, I will get a neutral salt. If I get a strong acid and weak base to react, I get an acidic salt. If I get a strong base and weak acid, then you may have guessed it is a basic salt and water heat is formed. So this is the basic concept of neutralization. Now, let us read through. So you can see that you can take suitable amounts of both. Because if you take more of the acid and less of the base, as I said, you will get a acidic salt rather than a neutral one. So the acid and basic nature both get destroyed. And the resulting solution is neither acidic nor basic, it's neutral. And if you touch the test tube immediately, there will be heat because heat is evolved, the temperature rises. Now, neutralization, it forms a salt. We need a product because a reaction is taking place, and the salt may be acidic, basic, or neutral, as I said. And the reaction between acid and base is known as neutralization. Salt and water are produced in this process with the evolution of heat. This is important, gives you a defining line. Equations. Now, equation, if you understand the concept, it becomes very simple. Now, acid plus base gives salt and water. This is the main idea. Acid plus base gives me salt plus water with some heat also. Gives heat. This example is very important, but you don't have to by heart this. I will tell you what is the concept behind this. So first of all, you need to know that hydrochloric acid is a strong acid. Sodium hydroxide is a strong base, which means I'm going to get a neutral salt, which is sodium chloride and water and heat. You can learn the chemical formulas of hydrochloric acid, HCl, sodium hydroxide, Na, sodium, OH, sodium hydroxide, sodium chloride formula, NaCl, water, H2O. We will react them and see how exactly this reaction is happening. HCl plus NaOH gives me NaCl plus H2O. Plus heat is also there. We will leave that for now. Now, I have hydrochloric sodium hydroxide. Okay. Now, this is the reactants part. We will see this later. Let us react these and see how we get these. Now, in this, I have a positive side, positive part, and negative. In this, sodium is positive, OH is a negative part. You will learn this later. There are ions. There are ions. I have a positive ion, negative ion, positive ion, negative ion. This is like a displacement reaction. You will learn these in higher classes, but just want to give you a gist. Now, as you know, unlike charges, they attract. They are not charges, but if you can learn it in this way, then you can remember. Unlike charges, positive and negative, they attract. This is one idea you know, right? Yeah. So similarly, the positive, negative, already they have attracted. But when they react, I'm going to do little crisscross. I'm going to do little bit of crisscross. Positive will go to this negative. And this negative will go to this positive. And by convention, positive part we always write first. I did not write OHNA because this is my positive part. This is my negative part. I wrote NaOH, so you cannot write it. This is by convention. It's a rule. So when I react them, I get NaCl. I got NaCl. Now this is H and OH. H and OH, then it's nothing but water, which is H2O. 2H and 1O, H2O. You can. This was just for your understanding so that there is nothing to get confused about when you learn this reaction, and you totally don't have to by heart this reaction. So now write this reaction along with me now that you know the concept. HCl plus NaOH gives H and OH react. You can write H2O plus Na and Cl, NaCl plus heat. You can similarly react any acid and base in this way. It will always form a water. It will always form a water that I'm getting from my OH and H. So acids will contain this H factor and bases will contain this OH. So as I told you beginning about Arrhenius concept, that acids give H plus ions, whereas bases give OH minus ions. So you can connect the whole thing together now. And whatever is here, will be my negative part, this will be my positive part, but positive comes first and you can react it and get the product with the evolution of heat. So I hope all of you have understood this. Now this is very, very, very important. That is applications. As important as concepts are, applications is very important. This is so important, very, very important. Each of the application. First, indigestion. Now, our stomach contains hydrochloric acid. We saw HCl is hydrochloric acid. Now, this is a corrosive acid. It's a strong acid, and that's why our stomach has mucus lining, which protects. This we did in nutrition in animals. It has a mucus lining, which protects the lining of the stomach. But sometimes the stomach may release too much of acid. Right? It may release too much of acid, which becomes harmful, and this indigestion becomes painful. So to relieve this, as this is an acid, I have to neutralize this excess acid. So I will add a base. So we will take an antacid. Antacid is actually a base which helps in relieving such excess acid issues. So milk of magnesia or magnesium hydroxide. I told you OH factor. It has an OH, it is having a hydroxide, it is a base. So milk of magnesia or magnesium hydroxide, the intake will neutralize. So all these applications have only one single concept. Acid plus base gives salt plus water with some heat, but it is basically a neutralization reaction. We are trying to neutralize everything so that it is all balanced. Next, ant bite. When an ant bites, it injects acidic liquid or formic acid. Also methanoic acid, you can call it. HCOOH. This is extra information. It injects formic acid. So we have to add a base to neutralize this effect. So moist baking soda, sodium hydrogen carbonate. Sodium hydrogen carbonate we have to add. It is a basic substance. So acid plus base, again we have acid plus base, neutralized to give some salt plus water. That salt plus water product we are not discussing, but we are going to discuss how we can neutralize such things. Now soil treatment. Sometimes the soil becomes either too acidic or too basic, but neither is preferred. Sometimes too acidic or too basic, but we want neutral soil. Plants are not adapted to either too acidic or too basic. We want a neutral environment for them to sustain. So we have two cases here. One when soil is too acidic, one when it's basic. So obviously if soil is too acidic, we add something basic. If it's too basic, we add something acidic. But what is that substance? When the soil is too acidic, it is treated with base like quicklime or lime water, or you can say lime, slaked lime. That is calcium oxide and calcium hydroxide. Quicklime is this and slaked lime is this. Now, if the soil is basic, what if it is basic? Then organic matter is added. Organic matter, it releases certain acids which neutralize the basic nature. So if it is basic, we'll add organic matter. If it is acidic, we add bases like quicklime and slaked lime. Now, factory waste. Now, factory waste contain acids, which means we have to treat it with the base. If not, if we release these acids into rivers, because rivers are like a disposal, the factory waste are disposed into rivers and water bodies. As written, wastes are disposed into the water bodies, and so the excess acid can kill fish and aquatic life and many organisms. So therefore, they are neutralized by adding basic substances so that the water becomes, or the solution or the base become neutral, so as to minimize the damage caused. Now, this is, I think, the most important part of the textbook in this chapter. Very, very important. So do not miss learning these two tables: acids, natural acids, and bases. I'll give a run through so that you can familiarize with them. Vinegar contains acetic acid. And sting, as we discussed, contains formic acid. You can say methanoic acid. Now, citrus fruits, in by its name, we have citric acid like orange, lemon, etc. Curd contains lactic acid. Uh, Milk is converted into curd by a bacteria known as lactobacillus. Lactic acid. The name is similar. Now, spinach contains oxalic acid. Even tomatoes contain oxalic acid. Then you have citrus fruits, amla, such as amla, and some other citrus fruits, vitamin C containing. They are ascorbic acid. Then tamarind, grapes, unripe mangoes, they contain tartaric acid. T for tartaric, T for tamarind. Now bases. Lime water, as I had just shown you in the previous slide, lime water. This is lime water, CaOH twice. Calcium hydroxide. Lime water contains calcium hydroxide. Window cleaners, ammonium hydroxide. Soap, there can be two kinds of soap. One is sodium hydroxide, one is potassium hydroxide. And also milk of magnesia, which is used as an antacid, as mentioned, is magnesium hydroxide, MgOH twice. So antacid, we saw the application, and this is a table. So this can be definitely asked for maybe 1 mark, or match the following, or name the following. But this is a sure question that will definitely come for most of the exams. So that was it for this lesson. I hope all of you enjoyed and understood this concept. And I hope I was able to help you learn this topic as well. If you were able to learn it, then do not forget to hit the like button, share it with your friends, and subscribe to the channel. Don't forget to turn on the notifications so that you don't miss out on any of the new videos. Until we meet again, bye bye and take care.